Bone tissue. Similar to other connective tissue, bone tissue have extracellular matrix and three cell types: osteocytes, osteoblasts, and osteoclasts. Osteoblasts are immature cells located at the surface of bone tissue side by side. Osteoblasts synthesize the organic components of the matrix. Matrix components are secreted at the cell surface, which is in contact with older bone matrix, producing a layer of new but not yet cultivated matrix called osteoid. Osteoid is a space between the osteoblast layer and the previously formed bone. Osteocytes, which derived from osteoblasts, lie in the lacunae. Lacunae are osteocytes and extracellular non-calcified matrix. Only one osteocyte is found in each lacuna. Osteocytes are mature cells. Osteoclasts are very large branch cells with many nuclei. Osteoclasts are derived from the fusion of bone marrow cells and belong to the mononuclear phagocyte system. Osteoclast secretes collagenase and other enzymes and promote the localized digestion of collagen and dissolving calcium salt crystals. Lysosomal enzymes packaged in Golgi complex. Osteoblasts and osteoclasts are functional antagonists. Osteoblasts are responsible for the synthesis of organic components of bone matrix such as type 1 collagen, proteoglycans, and glycoproteins, and osteoclasts destroy both collagen and calcium salts. Here are the osteoblasts and osteoclasts in the surface of bone tissue and osteocyte in the thickness of tissue. Inorganic matter represents about 50 to 70% of the dry weight of bone matrix. The organic matter in bone matrix is type 1 collagen and ground substance, which contain proteoglycans and glycoproteins. The association of hydroxyapatite with collagen fibers is responsible for the hardness and resistance of bone tissue. After a bone is decalcified, its shape is preserved, but it becomes as flexible as a tendon. On the other hand, after removing of the organic part of matrix, it becomes fragile, breaking and crumbling. Layers of bone-forming cells with connective tissue called periosteum and endosteum. Periosteum consists of an outer layer of collagen fibers and inner layer of osteoblasts. Endosteum simultaneously lines all internal cavities and cover all matrix within the bone. The principal function of periosteum and endosteum are nutrition of tissue and provision of a continuous supply of new osteoblasts for repair or growth of bone. Dense areas without cavities corresponded to compact bone, and areas with numerous interconnecting cavities corresponding to cancellous or spongy bone. In long bones, and that called epiphyses, are composed of spongy bone covered by a thin layer of compact bone. The cylindrical pen diaphysis is almost totally composed of compact bone within a small component of spongy bone in its inner surface around the bone marrow cavity. Short bones usually have a cord of spongy bone completely surrounded by compact bone. The flat bones have two layers of compact bone called plates, separated by a thin layer of spongy bone. In compact bone, the lamellae have a typical organization consisting of Haversian system, outer circumferential lamellae, inner circumferential lamellae, and interstitial lamellae. This is organization of compact bone. Outer circumferential lamellae, inner circumferential lamellae, Haversian system or osteon, and interstitial lamellae between osteons. And this is organization of spongy bone, trabecular, consisting of osteoblast, osteoclast that cover the trabecula. Trabecula consists of lamellae with lacunae consisting osteocytes. Or here, outer circumferential lamella, inner circumferential lamella, osteon or Haversian system, interstitial lamellae. Interstitial lamellae surround osteon or Haversian system. Each Haversian system or osteon is long cylindrical parallel to the long axis of the diaphysis. It consists of the central canal surrounded by 4 to 20 concentric lamellae. The osteon canals communicate with the marrow cavities and periosteum and another through the transverse or oblique Volkmann's canals. Each endosteum-lined canal contains blood vessel nerves. Lacunae contain osteocytes and found between the lamellae. Each lamella fibers are parallel to each other and follow a helic course. Fibers from adjacent lamellae intersect at right angles. The presence of large number of lamellae with different fibers orientation provides the bone with great strength.